Okay, configure the DHCP scope, yeah. So the DHCP scope configuration include the following step. Create a new DHCP scope and name the DHCP scope. Verify the new DHCP scope and configure and enable the new DHCP scope. Finally, verify and enable the DHCP scope. Okay, first of all, create a new DHCP scope. To configure a new DHCP server, scope, click internal DHCP server. Okay, next go to DHCP scope and click new, right? As shown in this figure. Okay, next, second, name the DHCP scope. The scope is named wireless management and then apply. So third, verify the new DHCP scope in the DHCP scope page. Click the new scope name to configure the DHCP scope. 4. Configure and enable the new DHCP scope. On the edit screen for the wireless management scope, configure a pool of addresses in example 192.168.200.240/24 until 249.249. Yeah. So the default router IPv4 addresses, example 192.168.200.1, then enable and apply. On next 5, verify the enable DHCP scope. The network administrator is returned to the DHCP scope page and can verify the scope is ready to be allocated to a new wireless LAN. Okay, this video will show how to configuring a WPA2 enterprise wireless LAN. All right.
Hello everyone, it is time to hook a company employee to a company data network using wireless. So in this scenario, we've got a company employee on a laptop, and they're going to be connecting to a wireless network that we're about to build. This wireless network is WPA2 with Enterprise. What that means is we're going to go on the wireless LAN controller, configure a new wireless network to be deployed to our access point, and we're going to utilize Enterprise with authentication. That employee is going to need a username and password combo to get on the wireless network, and our wireless LAN controller is going to take those credentials that are submitted by the user, and they're going to forward them over to PCA, which is running as our Radius server, and it'll get a response back and either allow or disallow that company employee on the company network. So let's get started in configuring the wireless LAN controller. So here we are on the dashboard of our wireless LAN controller. We're going to start by clicking on Advanced. Inside of Advanced, we're going to go to our section of Wireless Local Area Networks, and we're going to create a new one. So we have the drop-down set to create new. We'll go ahead and click on Go. And we're going to name this. The profile will be Company Name. Our SSID, the wireless network name that our users will see, will also be Company Name. And that ID value, we can leave it at 2. I'll click Apply, and now we have a lot more settings to look at. We'll enable this wireless network, and we're going to make sure that the interface is using our company data network, which is our VLAN 5. That's where the data is. VLAN 1 is our management network. We're leaving that alone. We can leave the rest of these settings at their default, and now we go to security. Inside of security, we see that we're allowing WPA and WPA2, but down below, we have 802.1x set by default. This is what we're going to utilize and use this in order to have our devices that connect to the wireless be requested for username password authentication. But we need to have those requests forwarded somewhere, and that's going to be our tab for the AAA servers. When I click on AAA servers, you'll see that no servers are currently selected. In a previous video, we actually identified a Radius server inside of our wireless LAN controller configuration. So in the server 1 dropdown, I can actually scroll down and I can select a previously identified Radius server. The port of 1812 is set, as well as the IP address, and this is the IP of PCA, which is running as the Radius server. We're not using any accounting feature, so we can leave that at the default of none. At this time, I can now click Apply, and now the company name profile has been deployed on a wireless LAN controller, and this wireless network will be shared out to our access point. Let's do some verification. So let's go ahead and click back, and we should be able to see this wireless profile now created. And here you can see it. Wireless LAN ID is 2. Remember that. It's a type of wireless local area network. The profile name we created was company name. And the wireless LAN SSID, which is the wireless name the users will see, is company name. We have this thing enabled, and we're using WPA2 with 802.1x for our authentication. That authentication being requesting usernames and password combos as our users connect to the wireless. But that's to verify that our wireless LAN controller can actually take a username and password combo that it'll receive from a PC, forward it over to our Radius server, and have the Radius server respond back with a successful authentication message. To do that, we're going to the console port of our wireless LAN controller. So here we are on the console port of our Cisco wireless LAN controller, and we're going to use two different commands here in order to verify that our wireless LAN controller itself can take a username password combo, throw it against the Radius server, and have the Radius server respond back with a successful authentication message. So to get started, we're going to use the command test followed by AAA, and we're going to use Radius. The username command followed by the username of Bob. Because you know what? One of our wireless clients might have a username of Bob. And followed with the command password. And Bob's password is probably hello. That's a nice combo. And then we're going to specify the wireless LAN ID. And this was that ID value we saw in the GUI, which was an ID of 2. And this was the profile company name with the wireless SSID, company name, and using WPA2 with our 802.1x authentication. So we're going to shoot this off to our Radius server, and we should get a response back. And let's take a look at seeing that response. To see the response, we're going to use the command test AAA followed by show Radius, and let's see what the server sent us back. Well, our server sent us back an authentication response result code success. We've successfully reached out to the Radius server from our wireless LAN controller with the credentials of Bob Hello, and the Radius server says that user is good to connect. This is awesome. Enjoy WPA2 with Enterprise targeting a Radius server on the wireless LAN controller.
All right. Okay, configure WPA2 Enterprise Wireless LAN. By default, all newly created wireless LAN on the wireless LAN controller will use WPA2 with Advanced Encryption AES. 802.1x is the default key management protocol used to communicate with Radius server. Next, create new VLAN, new wireless LAN to use interface VLAN 5. Configure wireless LAN on the wireless LAN controller. Include the following steps. First, wireless LAN. Second, create the wireless LAN name and SSID. Next, enable the wireless LAN for VLAN 5. And then verify AES security and 802.1x defaults. And next, configure wireless LAN security to use Radius server. Finally, verify the new wireless LAN is available. Okay, configure WPA2 or version 2 enterprise wireless LAN. First of all, step 1, create a new wireless LAN. So click wireless LAN tab and then go to create a new wireless LAN. Step 2, configure the wireless LAN and SSID. Enter the file name and SSID, choose an ID of 5, then click apply to create the new wireless LAN. So third step, or step 3, enable the wireless LAN or for VLAN 5. Once the wireless LAN change the status to enable, choose VLAN 5 or for the interface or interface group G. Drop down list and then click apply and click OK to accept the pop-up message. Step 4, verify AES for security and 802.1x default. Click the security tab to view the default configuration of the new LAN has been made. So step 5, configure the radius server. To select the radius server that will be used to authenticate wireless LAN users, click the AA server tab and in the drop box, the radius server that was configured on the wireless LAN controller previously, and then apply your changes. Next, verify that the new wireless LAN is available. To verify the new wireless LAN is listed, and enable click on the wireless LAN sub menu. Okay, so we have a packet tracer. You can try this in our NetAcad, which is regarding configuring a WPA2 enterprise wireless LAN on the wireless LAN controller. Yeah. Okay, you can have this in our website. 13.4 troubleshoot wireless LAN issue. So troubleshoot approaches. Network problem can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technician must be able to analyze the problem and determine the cause of error before they can resolve the network issue. This process is called troubleshooting. Troubleshooting any sort of the network should follow a systematic approach. A common and efficient troubleshoot methodology is based on the scientific method and can be broken into the 6 main steps shown in the table on the next slide. First, first step, identify the problem. So to identify the problem, the first step is to troubleshoot process is to identify the problem. While tool can be used in this step, a conversation with user is very helpful. Yeah. And the next step, theory of probable causes. After you have talked to the user and identified the problem, you can try and establish a theory of probable causes. This step often yields more than a few probable causes to the problem. Step 3, test the theory to determine cause. Based on the probable causes, test your theories to determine which one is the causes or cause of the problem. A technician will apply a quick procedure to test and see if it solves the problem. Sorry. If a quick procedure does not correct the problem, you might need to research the problem further to establish an exact cause. Step 4, establish a plan of action to resolve the problem and implement the solution. After you have determined the exact cause of the problem, establish a plan of action to resolve the problem and implement your solution. Step 5, verify full system functionality and implement preventive measures. After you have corrected the problem, verify it. Yeah, full functionality. If applicable, implement preventive measures. And lastly, document findings, action, and outcome. In the final step of the troubleshoot process, document your finding, the cause, and then action, the solution, and outcome, verify that. This is very important for future reference. Wireless client not connecting. If there is no connectivity, check the following. First, confirm the network configuration on the PC using the ipconfig command. Confirm that the device can connect to the wired network ping on the known IP address. Next, if needed, reload driver as appropriate for the client or try a different wireless network interface card or NIC. If the wireless NIC of the client is working, check the security mode and encryption setting on the client. If the PC is operational but the wireless connection is performed poor, check the following. Is the PC out of the plan cover area BSA? And then check the channel setting on the wireless client. Next, checks for interference with the 2.4 gigahertz band. Next, ensure that all the devices are actually in place. Consider a possible physical security issue. Is there power to all devices and are there power on? Finally, inspect link between cable devices looking for bad connectors or damage or missing cables. If the physical plan is in place, verify the wired LAN by pinging devices including AP. If connectivity still fails at this point, perhaps something is wrong with the AP or its configuration. When the user PC is eliminated as the source of the problem and the physical status of devices is confirmed, begin investigating the performance of the AP. Check the power status of the AP. Troubleshooting when the network is slow. To optimize and increase the bandwidth or 802.WLAN. So sorry, 802.11, this one for wireless standard. Dual band and APs, either upgrade or split the traffic. Okay, for the upgrade your wireless client, older is 802.11, B, 11G, and also 11N. Devices can slow the entire wireless line. For the best performance, all wireless devices should support the same highest acceptable standard. Another way, split the traffic. The easier way to improve wireless performance is to split the wireless traffic between 802.11 and 2.4 gigahertz band and the 5 gigahertz band. Therefore, 802.111n or better can use the two bands as to separate wireless network to help manage the traffic. There are several reasons for using a split the traffic approach. First, 2.4 gigaband may be suitable for basic internet traffic that is not time sensitive. And the bandwidth may still be shared with other nearby wireless LAN. And then the 5 gigahertz band is much less crowded than the 2.4 gigahertz band, ideally for streaming multimedia. And next, maybe 5 gigahertz band has more channels, therefore channel is chosen likely interference free. Okay, that's a reason for using a split the traffic approach. By default, dual band routers and AP use the same network name on the both the 2.4 gigahertz band and 5 gigahertz band. It may be useful to segment the traffic. The simplest way to segment the traffic is to rename one of the wireless network. To improve the range of wireless network, ensure the wireless router or AP location is free of obstruction, such as furniture, fixtures, and tall appliances. This block the signal actually, which shorten the range of the wireless LAN. If this still does not solve the problem, then Wi-Fi range extender or deploying the power line wireless technology may be used. Updating firmware. Most wireless router and AP offer upgradable firmware that should be periodically verified. On wireless LAN controller, there will most likely be the ability to upgrade the firmware on all APs that the wireless LAN controller control. In the figure, the firmware image that will be used to upgrade all the APs is downloaded. On Cisco 3504 wireless controller, click wireless access point and go to global configuration and then scroll to the bottom of the page for the AP image pre-download section. So here are the packet tracer regarding troubleshoot wireless LAN. In this packet tracer, you will complete the following objective, which is troubleshoot wireless LAN, connectivity issue in home enterprise, and troubleshoot wireless LAN connectivity issue in an enterprise network. Okay, 13.5 module practice and summary. Okay, so we got packet tracer regarding wireless configuration. You can do it this. Okay, in this packet tracer, you will configure both wireless home router and wireless LAN controller based network. You will implement both WPA to PSK and WPA to enterprise security. And then you have to configure this home router to provide Wi-Fi connectivity to a variety of devices. Configure WPA2 PSK security on home router and configure interface on a wireless LAN controller. Configure WPA2 PSK security on wireless LAN and connect host to the wireless LAN. And next, configure WPA2 enterprise on wireless LAN and connect host to the wireless LAN. And finally, verify all the setting through the verify the connectivity. Okay, there is a packet tracer physical mode as well. So wireless LAN technology exploration. Okay, in this packet tracer physical mode activity, you will complete the following objective. First part, explore the wireless network. Yeah, and then add Wi-Fi to a boardroom, add wireless connectivity to the coffee shop in the cellular dead zone, and then part 4, add wireless connectivity to a home office. Okay, try do this. This is also very interesting activity. Okay, that's all. Thank you for watching. See you in the next module. Bye-bye.